Good afternoon, students. Today we will discuss the topic congruence modulo. In previous video I have discussed about the topic modulo arithmetic. If you want to watch this video, then you have to check my description box. I will give the link of the previous video in the description box. And one thing I would say in the starting of my video, that if you like my channel, please do subscribe, share with your friends, family, because that will help you to learn mathematics in easy way. Okay, so let's start. Today we will discuss the topic congruence modulo, and we will understand the concept by taking an example. How? Let's check. So move to the next slide. Okay, now if we divide 15 by 7, then what will happen? If we divide 15 by 7, then what will happen? So if we divide 15 by 7, then the remainder we get 1. Okay, now let us divide another number, which is minus 6, by the same divisor 7. Okay, minus 6. Now here the dividend is minus 6, okay, and the divisor is 7. That is, here a less than b, the dividend is less than the divisor. In that case, either we will take the quotient 0 or the negative quotient. Now if we take the quotient 0 here, then we get the negative remainder, which is not possible, so we take the quotient minus 1. Okay, so 7 into minus 1, that is minus 7, and if we subtract, then we get minus 6 minus of minus 7, that is minus 6 plus 7, 1. Now one thing have you observed here? We have divided two different integers by the same divisor and got the same remainder. In that case, we say 15 and minus 6. 15 and minus 6 both leave same remainder, when divided by 7, right? In that case, we say 15 is equivalent to minus 6 mod or modulo 7. Okay, 15 is equivalent to minus 6 mod 7. In other words, we can say that 15 is congruent to minus 6 mod 7. 15 is congruent to minus 6 mod 7, and symbolically we write it as 15 congruent to minus 6 mod 7. This is the symbol of congruency. This is the symbol of congruence. Okay, so when we divide two different integers by the same divisor and got the same remainder in both cases, then we can say that these two integers are equivalent to each other mod that divisor. Like if we divide two integers a and b by the divisor n and got the same remainder, then we can say that a is congruent to b mod n. Okay, and that is the concept of congruent modulo. I hope you all have understood. So we say integers a and b congruent modulo n if their difference is a multiple of n. If their difference is a multiple of n, you can see by this example 15 15 minus of minus 6. What is the value? 15 plus 6, that is 21, and we know that 21 is divisible by 7. 7 is a divisor of 21, and that we can write as 7 divides 21. That is, we can say that two integers a and b congruent modulo n if their difference is a multiple of n. Another example, 17 and 5 are congruent modulo 3 because 17 minus 5, which is equal to 12, and which is a multiple of 3 because 12 can be written in the form 4 into 3. Therefore 12 17 congruent to 5 mod 3. 17 congruent to 5 mod 3. In another way, we also can prove this if we divide 17 by 3. What is the remainder? The remainder comes 2. In similar way, if we divide 5 by 3, we get the same remainder. So in that case also we can say that 17 and 5 are equivalent to each other mod 3, right? Also we can say that 17 is congruent to 5 mod 3. Another example, 184 and 51 are congruent modulo 19. Why? You can prove this in two ways. Find the difference. What is the difference of 184 and 51? That is 133, and that is the multiple of 19. That can be written as 7 into 19. Therefore we can say that 184 congruent to 51 mod 19. In another way you can prove this. Divide 184 by 19 and 51 by 19. You can check, you will get same remainder. In that way also you can prove this. Okay, so what we can conclude, two integers a and b are congruent modulo n if their difference is a multiple of n. Now the expression minus 8 congruent to 10 mod 9 is pronounced as negative 8 is congruent to 10 modulo 9, or sometimes negative 8 is congruent to 10 mod 9. Modulo 9, mod 9 both are same. You can say in any way. Okay, a familiar usage of modular arithmetic is whenever we convert between 12 and 24-hour clocks. Like we know that 14 and 2 p.m. indicate the same time because 14 congruent to 2 mod 12, or you can say if we divide 14 by 12 we get the remainder 2. In similar way, if we divide 2 by 12 we get the same remainder 2. So 14 congruent to 2 mod 12. Okay, I hope you all have understood the concept of congruence modulo. Next slide we discuss the formal definition of congruence and an important remark. If n is a positive integer, one thing you always have to remember, the modulo you are taking is always a positive integer. Okay, if n is a positive integer, we say that two integers a and b are congruent modulo n, and write a congruent to b mod n. One more time I am telling you, that is the symbol of congruent. Okay, and mod n and modulo n both are same. And in another way you also can express this definition, a congruent to b mod n, if they have the same remainder on division by n. Like if you divide the integer a by n and the integer b by n, in both cases you will get same remainder. From that case also you can say that a congruent to b mod n. Important remark, a congruent to b mod n if and only if n divides a minus b. A congruent to b mod n if and only if n divides a minus b. Now n divides b minus c. This symbol divides is not equivalent to the symbol of division. Okay, this symbol and this symbol are different, they are not same. N divides a minus b means n is a divisor of a minus b. Like if I say 5 divides 10, that means 5 is a divisor of 10. That is not equivalent to 5 divides 10. Okay, most of the students get confused by these two symbols. The symbol of divides and the symbol of division, both are different. 5 divides 10 means 5 is a divisor of 10. How we can say that? Because we know that 10 can be written as 5 into 2. So 5 is a divisor of 2, also 2 is a divisor of 2, and from this we can write 5 divides 10. Also you can write it as 2 divides 10, and 5 divided by 10 means half. So both are different. So here the meaning of n divides a minus b means n is a divisor of b. N is a divisor of a minus b. And if I say the formal definition of a divides b, this implies that b is equal to a into k, where k is any integer, and that means you can say that a is a divisor of b. Okay, a divides b means a is a divisor of b. So what is the remark here? A congruent to b mod n if and only if n divides a minus b. That means if a congruent to b mod n, then n divides a minus b, that is n is a divisor of a minus b. In opposite way, if n divides a minus b, then a congruent to b mod n. This remark will help you to solve the questions regarding congruence modulo. So remember it always. If a congruent to b mod n, then n is a divisor of a minus b. In similar way, if n is a divisor of a minus b, then a congruent to b mod n. I hope you all have understood the definition of congruence. Now move to the next slide. In next slide we discuss about the properties of congruence modulo n, and these properties are very much important, that would helps you to solve the questions regarding congruence modulo. So understand it very carefully. If you have any question regarding anything, you may ask in the comment section. I will clarify in the next video. First property says that a congruent to a for any a. Now a congruent to a for any a, one thing is common in each and every property, that is mod n. That is why in the first line I have written congruence modulo n satisfying the following. So mod n is in every property, okay, that you have to consider. So first property says that a congruent to a for any a mod n. For example, how we understand this? We can say that 1 congruent to 1 mod 2. Now how we understand this? In previous slide we have discussed about important remark, that is a congruent to b mod n if and only if n divides a minus b. Okay, now we check whether 2 is a divisor of 1 minus 1 or not. Now 1 minus 1, that is a minus a, is equal to what? 0. right? And you can write 0 as 0 into 2, and from this what we can conclude, 2 is a divisor of 0. Therefore we can write it as 2 divides 0, and 0 means here what, 1 minus 1. Therefore 2 divides 1 minus 1, and if 2 divides 1 minus 1, therefore what we can write, 1 congruent to 1 mod 2. So if we replace 1 by a and 2 by n, then in general what we are getting, a congruent to a mod n. I hope you all have understood. So the first property says every integer is congruent to itself mod n, where n is a positive integer. Now move to the next property. A congruent to b mod n implies b congruent to a mod n. How? Acha, a congruent to b mod n, what does it mean? According to the remark, we can say that n divides a minus b, right? N divides a minus b. Now we can write a minus b as minus of b minus a, isn't it? N divides minus of b minus a. Minus of b minus a and a minus b both are same. Therefore what we can write in the next step, n divides the factor b minus a. If n is a factor of minus of b minus a, then obviously n is a factor of b minus a, because see, 5 is a factor of 10. From this we can easily conclude that the 5 is a factor of minus 10, because 10 can be written as 5 into 2 and minus 10 can be written as 5 into minus 2. So if n is a divisor of minus of b minus a, then obviously n is a divisor of b minus a, and n divides b minus a. According to the remark, what we can write, b congruent to a mod n. Therefore we have proved from the property a congruent to b mod n is b congruent to a mod n. Okay, therefore a congruent to b mod n implies b congruent to a mod n. I hope you all have understood. If you have any question, you may ask in the comment section. I will clarify in the next video. I am telling the same thing repeatedly because of you. Okay, move to the next property. A congruent to b and b congruent to c implies a congruent to c. Okay, therefore it means if a congruent to b mod n and b congruent to c mod n satisfies together, from this we can conclude that a congruent to c mod n. How? A congruent to b mod n, a congruent to b mod n, according to the remark, what we can write, n divides a minus b, isn't it? In similar way, b congruent to c mod n, that implies what, n divides b minus c. Okay, understood? Now n divides a minus b. We know that according to the definition of a divides b, b can be written as b equal to a into k, as a is a divisor of k, divisor of b, right? Therefore here also we can write the same, a minus b equal to nk, and here we write b minus c equal to nk1, another integer k1. Okay, now consider this as 1 and this as 2. Now add these two equations, add left hand side to left hand side and right hand side to right hand side. So what we get, a minus b, 1 plus 2. Okay, we are doing 1 plus 2. a minus b plus b minus c equal to nk plus nk1. Now minus p and plus p will be cancelled out and we get a minus c, which is equal to n is common in both terms. We can write it as n into k plus k1. Now from this what we can say, n is a divisor of a minus c. Here we get a minus c equal to n into k plus k1. Now k is an integer, k plus 1, k1 is also an integer, so k plus k1 is also an integer because addition of two integer is an integer, right? So this is another integer that we can write as nk2, right? Therefore a minus c equal to nk2. Therefore what we can conclude, ki a minus c equal to nk2, n is a divisor of a minus c, so n divides a minus c and n divides a minus c. According to the remark, what we can write, a congruent to c mod n, a congruent to c mod n. Okay, therefore if a congruent to b mod n and b congruent to c mod n implies what? A congruent to c mod n. I hope you all have understood. Now move to next. A congruent to 0 if and only if n divides a. Very simple to prove this. A congruent to 0. Achha, if and only if means we have to prove both the sides. Like first we consider a congruent to 0. From this we prove n divides a, and in the next part we consider n divides a, and from this we prove a congruent to 0. So first we have considered a congruent to 0. Okay, and according to the remark, what we can write, n divides a minus 0. Therefore a minus 0 is a, so n divides a. So the first part is proved. That means if a congruent to 0, then n divides a. Next we prove the second part. We consider first n divides a, and from this we prove a congruent to 0 mod n. Okay, n congruent to 0 mod n. Now we can write a as a minus 0, right? Therefore what we can write, a minus 0 congruent, a minus 0, n divides a minus 0 means a congruent to 0 mod n. Okay, therefore it is proved कि if n divides a, then a congruent to 0 mod n, and combining these two, what we can say, a congruent to 0 if and only if n divides a. Here I double f means if and only if and only if. Okay, I hope you all have understood the fourth property. Now move to next. Congruence modulo n satisfies the following. Fifth property says a congruent to b and c congruent to d mod n implies a plus c congruent to b plus d mod n. So here two congruency given, and you can add these two congruencies, that is also satisfying mod n. Like here we have added left to left and right to right, and till it is satisfying. Let's take an example. We know that 10 congruent to 5 mod 5. Why? Because 5 divides 10 minus 5, 5 divides 5, and also 20 congruent to 10 mod 5, right? Now we check whether 10 plus 20 is congruent to 5 plus 10 mod 5 or not. So let us add 10 and 20. If we add 10 with 20 and 5 with 10, then what we get? We get 30, and here we get 15, and we know that the 30 congruent to 15 mod 5. Why? Because 5 divides 30 minus 15. 5 divides 30 minus 15 because 5 is a divisor of 15. Therefore we can say that if A congruent to B mod n and C congruent to D mod n, then A plus C congruent to B plus D mod n. In similar way, A congruent to B, if A congruent to B mod n and C congruent to D mod n, this implies A minus C congruent to B minus D mod n. That is similar for subtraction also and similar for multiplication also. So seventh property says that if A congruent to B mod n and C congruent to D mod n, this implies AC congruent to BD mod n. Okay, now property 8, A congruent to B mod n, this implies that AK congruent to BK mod n for all integers k. That means if we multiply both sides by an integer, that doesn't affect the congruency. For example, we know that 14 congruent to 7 mod 7. Now let us multiply both sides by 2 and you can check that doesn't affect the situation. Like if we multiply both sides by 2, then in left hand side we get 28 and right hand side get 14, and we know that 28 congruent to 14 mod 7. Therefore we can say that if A congruent to B mod n, this implies AK congruent to BK for all integers k. That means we can multiply both sides by integer constant that doesn't affect the situation. Okay, so that is about the properties of congruence modulo n, and that would help you to solve the questions regarding this topic. In next video we discuss some important questions regarding this topic, congruence modulo n. Okay, we solve exercise 1.1 from the book ML Agarwal. And one thing I'd say in last, if you are liking my video, then please do subscribe my channel, do share with your friends and family. Hope it will help you to learn mathematics in easy way. That's it for today. Thank you so much for attending my video. Thank you.